Okay, we are going to test the RP. This is a 3/4 inch Combraco. The direction of flow is going this way. We have test cocks 1, 2, 3, and 4. Check valve 1, check valve 2, and the relief valve. We have shut off valve number 1 and shut off valve number 2. We'll be using a Midwest 830 test gauge. We're using this one because every valve is clearly marked and labeled. First thing we're going to do is flush this assembly. So we'll open 4, leave it running. Open 3 and we'll close it. Open 2 and close it. I'm not opening up these test cocks very much because I am in a lab. My test adapters are already in. I don't have a lot of debris. I do have strainers upstream of this assembly. Alright, so I'm going to take my high side hose and attach it to test cock number 2. I'm going to take my low side hose and attach it to test cock number 3. The low is on the back side of check valve 1. The high is on the front side of check valve 1. This time I will slowly energize the low and I will be bleeding low. I'm going to leave it running, again maintaining flow. Then I'll open the high and I will bleed high. I'm removing the trapped air if there is any. So I'll close the high. Now I will close the low. This time I am watching my needle to see what is actually occurring. And as soon as I close shut off valve number 2, this is going to tell me something very important. My needle stayed in position. If it had fallen and the relief valve had opened, that would have told me that check valve 1 was apparently not operating properly. I am making a note of that right now. I am, however, not recording it. Just putting a mental note that it appears to be working. Alright, first thing I'm going to get after I do that is I'm going to record my line pressure, roughly around 100 psi. Next, I will see at what point the relief valve will open at. To do that, what I'm going to do is place my hand under the vent, under the discharge. I'm going to slowly open the high side, 1 full turn. Then I will open the low side, no more than 1/4 of a turn. If I have to open the low more than 1/4 of a turn, that tells me that I have flow moving through the assembly. So the relief did open around 2.7 psid. Close that low back up. So the relief opened at 2.7, it only had to open at 2. It's doing fine. Next item on the agenda is I will be testing check valve 2 for back pressure. To do this, I am going to be pulling pressure from the front side of check valve number 1 and placing it on the very back side of check valve number 2. I will be utilizing my vent or bypass hose to do this and my control valves. The high is currently open, so I just have to open the vent and that will put water into my vent hose. Now I open it up, the water is running, and I will be attaching it while it is running. What that will do is actually remove the air out of that line. So as soon as I get that tight, I will cut the vent back off, isolating that flow. Now I'll open test cock number 4. Alright, now what I need is to get on differential. What I'm looking at is the effects after I open the relief valve, so my differential is lower. What I need to do is actually flow water through check valve number 1, and do that, all I do is open the low bleed. And all that's doing is coming over here and drawing water out from the back side of check 1. Therefore flowing water over it, putting check valve number 1 back in its normal operational position. So I'll flow it, then I'll cut it back off. The needle will fall and stabilize. Once it stabilizes, that's the normal operating differential of check 1. So I'm going to see what happens when I apply back pressure. So I open the vent. The needle may drop a little bit because what we're actually doing here is pushing on this check valve, which should increase the pressure slightly. You'll see it more on larger assemblies versus the smaller ones. But it may have dropped 1/10 of a psi, not very much here. I don't care anything about the value itself because all we're doing is looking to see if that check valve is actually holding. So check valve 2 is actually holding. If it was not, it would have, my needle would have dropped and the relief valve would have began to discharge. All right, so check valve 2 is holding tight under back pressure. Now I will reach over here and I'm going to reestablish once again. And what this is going to do is actually give me the differential for check valve number 1. Okay, the needle appears to have settled, looks around 7.0 psi-d. Very good. The reason we waited for this long is because we may have a leaking number 2 shut-off valve, may have had back pressure coming back through check valve 2. But after we have done the back pressure test on check 2, if this was leaking with flow downstream, it would have been compensating for it. If check valve 2 was leaking at the time and we didn't know it, this would have told us immediately because the relief valve would have began to discharge because we created the back pressure. So the relief opens, check valve 2 is holding tight under back pressure, and check valve 1 is holding a proper differential. So at this time, the next item on the list I want to look at is going to be shut-off valve number 2. Now I am currently pulling water out of the high side and sending it through my vent or bypass hose into the back side of check 2, which in turn is compensating for a small leak in shut-off 2 if it exists. So we will see if it exists. So since I'm just simply moving water around, all I have to do is cut the supply off. So I'll reach down here to test cock 2, killing the supply. The high side hose, or the high side of the assembly, is what actually establishes your reading on your gauge. So by cutting off that supply, if that water was moving out of the vent and out of the assembly, my needle should drop. However, it is not dropping. What that tells me is that shut-off number 2 is properly working. So I'll move on. I'm going to close my test cocks 3 and 4, and I'm going to perform one more optional test. I'm going to disconnect my hoses, bleeding everything off so I do not get wet. Done with the vent bypass hose. And what I'm going to do now is get a differential for check valve number 2. This is generally considered an optional test, but there is a good reason for doing it. When we applied back pressure previously, we pushed this check closed, which means we helped it or assisted it in working properly. Sometimes, and this can occur, check valve 2 will hold tight under back pressure, yet it will fail to hold a differential in its normal direction of flow. If we had indicated that shut-off 2 was leaking any point in the prior testing, this test right here would not be possible because flow would actually change our differentials in the assembly. So I've made sure all my valves are closed. My hoses are now attached. I am once again going to slowly energize the low first, and then I will bleed low. This ensures flow again through the assembly. Now I'll open my high side, and then I will bleed high. Get the air off, remove the air. Close high, let the needle peg out, get the air off, then I will close my low. At this point, the needle will fall, and hopefully it will settle. And it does. Settled at roughly 2.0 psi-d, which is a good value. That's what we wanted to see. So we have actually completed the entire assessment of this assembly. So what we'll do is turn our test cocks off. We will now remove our hoses. Open all our valves so we do not have any water sitting in our test gauge. And we will slowly re-energize the customer service line. And that is how we test the RP.